Hello everyone, my name is Srikanth Machiraju. I work as a senior consultant at Microsoft. I'm an author and a blogger as well. Today we are going to learn to run UI automation tests using Selenium Grid and Azure Container Service. The following are the prerequisites of this course. You can download the slide deck from the description below. Before going any further, let us understand the problem statement. Most of the successful companies like Google, Amazon, Microsoft, and Netflix, they do deployments very frequently. Like Amazon does a deployment every 11.6 seconds. Netflix does thousands of deployments per day. That's how they beat the competition. They deploy faster, they get the feedback from the users, and they build and deploy again. This is possible because they have a very stable and a fast and a performing continuous testing stage in their release pipeline. Now, how do you think we can achieve that as well? Let's assume that you have a web application and it has around 1,000 test cases. What is the optimum way of testing it? Manual test cases obviously is the most cumbersome way of doing it because to run 1,000 test cases would take days or weeks. And let's say if you have to support multiple browsers, the amount of time it takes to run those manual test cases would increase exponentially. UI automation test is obviously the fastest and the most productive way to test a UI intensive product like a web application. Let's assume that you have automated the 1,000 test cases. Now, what does it take to run those UI automation tests? Assuming that a UI test case takes 2 minutes to run, and if you run them sequentially, it would take 1.5 days. And if you want to support multiple browsers, again, it would increase exponentially. So running the UI automation tests sequentially is not suitable for a large application. So how do you do it? You do it using Selenium Grid. Selenium Grid allows you to run your tests parallelly using different machines against different browsers in parallel. So let's understand what Selenium Grid has to offer. Selenium Grid is a tool from Selenium. It can be used to run UI automation tests in parallel on different platforms or browsers. It is built using Java. The Selenium Grid architecture contains of a hub and one or more nodes. When you create a Selenium Grid, you give the test suite to the Selenium Grid, and it takes care of distributing this job to the nodes, and in turn returns the result to you. Higher the number of nodes, the higher the parallelism you would achieve. So how do you set up a Selenium Grid infrastructure before you run the test in parallel? So these are the steps here, the Java jar Selenium command, which can be used to create a hub and nodes. But the question is, where do you create this cluster? So there are two ways. You can create this cluster on your local desktop machine or on a server machine. But the challenge is the number of nodes, as in when you increase the number of nodes, the time it takes to run the test would decrease because it is always constrained to the host, the machine which is hosting the whole cluster. You can also create a cluster of machines, like you can have one machine for the hub and you have two or three machines running the nodes. But again, managing the infrastructure is a headache. So you would need a cluster which can be managed easily and which can scale to an infinite level so that you can run your tests in parallel and in seconds. So let's see what Azure has to offer. Azure Container Service is a new offering from Microsoft Azure. This Microsoft Azure Container Service is it's abbreviated as AKS. So before understanding what Azure Container Service is, let's step back and understand what containers are. I'm not going to go in detail into the containers or the or in detail into the containers or imaging, but I want to give the brief introduction of the each of the elements of the container services. So a container is an instance of a deployment. Let's say you have a web application. How do you deploy a web application? You copy the files to a web server like IIS, and you open a browser and point to the URL, and your application is up. But let's say you have wrapped the files of the web application into a zip file. So this becomes your container. So a container is actually contains the whole deployment, which can be used multiple times to create multiple instances of that deployment. Now, what is the container image? The container image is a template for the container. It's like an ice tray which you can use to build multiple ice cubes of the same type. Now, what is a pod? The container and the container images are the definitions from the Docker world. A pod is from the Kubernetes world. The Kubernetes is a cluster environment from Google. So a pod is something which wraps the container in a Kubernetes world. So assuming that a pod has a single container, so a pod is a unit of deployment in the container world, in a Kubernetes world, sorry. A service is an endpoint to reach those pods. Let's say, for example, you put this application, you convert the web application into a container and you put the container into a pod. A service is a URL to reach that particular pod. A node is a host for the pods, like it's a machine. You can see the blue icon, blue box here, that is a Kubernetes node. A node can host multiple pods. A master, on the other side, is another machine which is managing the jobs and the nodes as well. Like in this Selenium hub and the node architecture, the master is the one which is managing the jobs, and it controls the job which is given to the pods, and it manages the life cycle of their pods. So that in brief is the definition of the Azure Container Service. For more details on the Azure Container Service or Docker, you can visit the references section to learn in greater detail. Now, the reason ACS is abbreviated as AKS is because Azure has two offerings for Azure for a container cluster. One is called Azure Container Service, and the second one is called Azure Container Service as well, but it is abbreviated as AKS, and it's also called as a Managed Azure Container Service. The reason it is called as managed Kubernetes cluster is because the master here is for free. So Kubernetes becomes the first class citizen in an Azure world, so that you don't have to worry about managing the Kubernetes master. So you just spin off nodes, and you get a console to manage the nodes, and you don't have to pay for the master. You just pay for the nodes. The number of VMs, the more you pay for more you pay overall. So that is the brief introduction of the Selenium Grid and the Azure Container Service. Now, with that understanding, let's understand the solution of a problem statement. The problem statement was that we wanted to run UI automation tests faster, so that we can deploy faster. So the solution here is to run the UI automation test by deploying a Selenium Grid on an Azure Container Service, managed container service. So let's see how to do it. So here to create an Azure AKS cluster, I'm using Azure CLI, but you can use the portal or the PowerShell as well. So as a first step, let me log in to the my Azure account. So it gives me this URL. So put the code. So I should be signed in a couple of seconds. So there you go, I'm signed in. Let me just clear that screen. And the first step in order to create a Azure Container Service Managed Cluster is to create a resource group. So here I'm creating a resource group in East US. So since it's already existing, let me just change the location to Central US. It doesn't matter, you just create a resource group anywhere. Right, so the resource group is created. So the next step is to ask the Azure command line to create an AKS cluster. So this by default creates a AKS cluster with 3 nodes, and each node is of size DS3v2. Let me just show once the cluster is up. So it would take a couple of minutes for the cluster to be created. So there you go, it has created the cluster. It just took more than a couple of minutes. Knowing that it is in the preview state, that should be okay. So in the browser here, you can see that the cluster is created, and I have 3 nodes, each of size standard DS1v2. So I can increase the number of nodes by adjusting the count here and clicking on save. So let's step back and understand what we have done so far. So we have created an Azure container service cluster which contains of 3 pods, and the master, as we know, is for free. So how do you manage this cluster? Now, the easiest way and the most intuitive way to manage the cluster is by connecting to it from the Azure CLI. So this command here connects you to that cluster from the Azure CLI. Right. So how do you connect and manage the cluster? So kubectl is a tool which can be used to create pods or manage the jobs on a Kubernetes cluster. So the first command here actually creates a pod using the Selenium hub image on port 4444. So let's just run this command from the Azure CLI. You can see that kubectl is directly connected. Let's just as you can see, I have connected to the Azure Container Service cluster using the command above. And the moment I've run the command, it allows me to run the commands using the kubectl tool. So using the kubectl tool, I have created a Selenium hub pod. The deployment is done. Now I'm going to expose the particular pod so that I can access it. Now the pod is exposed as a service. Um, how do you get to the URL? So just run the command, and it would take a couple of seconds for the external IP to be created so that you can access from your browser. So while it's doing that, let's open another PowerShell window and try to connect to the Kubernetes dashboard. So you can also connect to the Kubernetes dashboard. If you from the Kubernetes world, you would understand that the Kubernetes dashboard is the most, it has the Kubernetes dashboard has all the details that are required for you to manage the cluster and get the current state of the cluster. So you run this command to get the URL of the Kubernetes cluster. So it immediately opens a browser and points it to the Kubernetes cluster. As you can see, there is one deployment called Selenium Grid, and there is one pod called Selenium Grid which we just created. The number of services are 2. Kubernetes is a service which comes with the cluster when you use Azure ACS, so you don't have to worry about that, but you can see the service is being created. Let's just wait for a minute for the service to be created so that you can access the hub. So you can see that Selenium Hub service is now exposed, and this is the IP where you can reach the Selenium Hub. So that's the Selenium Hub. So let's come back to our presentation and understand what we have done. So we have created a Kubernetes cluster with 3 nodes, and we have created a pod. The pod contains the Selenium hub, and we have a URL to reach to that hub. So the next step is to create the nodes. Each node will be created as a pod in the Kubernetes cluster. So this is each pod will be a Selenium node. So let's do that. So let's run this command to create one node using the Selenium node Chrome 3.3.1 image, as this is a Docker image, pre-built image, and this runs on the Kubernetes cluster, and it is connected to the Selenium hub, which we have created above. So the moment the node is created, it points to the hub, and it notifies the hub that I am ready to take the jobs. So let's run this here. Let's maximize this. There you go. The Selenium node is created. You can watch it by clicking on the console here. Let's just give it a minute to appear. If you can see the number of pods from the Kubernetes cluster dashboard, you see that the pod is being created. So the node is created. So if you just refresh the grid console, you would see that a node is ready. So what do we do next is we scale the number of nodes to 10. So you have 10 pods which can take the UI automation jobs. So running this command would should initiate creation of 10 pods. Just go to the overview and you'll see that pods are being created. So as in when the pods are created, you can just refresh this console to see that the pods are coming up. Let's just wait for a couple of seconds for all the 10 pods to uh, come live. So all the 10 pods are live and active. You can check from the grid console as well. The pods have only one WebDriver for now, which runs the Chrome browser, but you can install multiple browsers on each pod so that you can run your UI web test on multiple browsers. The highlighted Chrome icon shows that the pod is not running any jobs at this point. Now, if you click on the logs of any of those nodes, you will also see that the node has successfully registered with the Selenium hub and it's ready to take jobs. Now, to run the jobs, I have created a sample solution which you can also refer from the GitHub. Let me show the GitHub URL. I'm sorry, it's on the prerequisite section, so you can download the solution from the GitHub here. All right. So first step is you run you make sure the build is successful and your test settings is pointing to the run settings file here, this file over here, because it's going to pick up the settings from here. So in order to have a frame of reference, I'm going to run this test sequentially first. So in order to do that, you have to make the disable parallelism as false. And if I run the test now in a sequential fashion, it would, I'm sorry, just cancel that. So I just to make it true. So ensure that disable parallelism is true and click run all. So it would execute one test, and this test basically Googles for a particular word and just goes to the home page of that particular whatever is the first on the search result. So it's running each test sequentially. So it has finished running the test sequentially. So overall, it has taken 1.51 seconds. So it's 1 minute 51 seconds. So it was using a Chrome WebDriver, which is on my local machine. Now let's try to run this test parallelly on the Selenium hub, which we have created on the AKS cluster, and notice the difference. So the changes I make here is I remove the local reference to my local WebDriver, and I point it to the hub we just created. The URL to the hub can be picked up from here. So this is the IP, and you'll have to always point it to wd-hub. And the other change which you need to do is to make this false. Now let's run the test. So it has started running the test, and you can notice from the window here that the moment the Selenium node picks up the test, it gets grayed out. So what is happening in the background is the job is posted to the Selenium Hub here, and the Selenium Hub distributes the job to all the Selenium nodes it has, and everything is running on AKS managed cluster. So it should be, let's just refresh to see if the tests are running. Yeah, they can see some pods grayed out. So it has finished running the test and it just took 40 seconds. So that's the difference you get by running tests on Selenium Grid on an AKS cluster. Um, now, once you are finished running the tests, right? So you can go ahead and delete the node. So this is the command you can run to delete the cluster. Make sure you're saving the cost. Let me just check what is wrong. Okay, so this is the command you run to delete the grid. Not yet. Right. Say yes, and you can see that the grid goes to the deleting stage. So this way you spin up a cluster in minutes. You deploy Selenium Hub, run your tests on that Selenium Hub, and they collect the results. And by the way you collect the results is by taking screenshots. So if you go to the bin folder debug window, you will see that the screenshots are available here from a successful test or a failed test. And you can, once the results are available, then you go ahead and delete the cluster. So that's all I had to show in this course. These are the references which you can go to and learn each of these concepts in depth. So to summarize, what we have done today is we understood the problem statement, which is to ensure that the tests are running within minutes, and we are able to deploy faster, test faster, and deploy faster. And we have understood that Selenium Grid is one of the possible solutions. How the Selenium Grid works, it contains a hub and one or more nodes. The Selenium hub takes the job and distributes the job to the nodes depending on the type of browser you have chosen. In order to run the hub and the nodes, you can use Azure Container Services managed containers cluster. So we have used Azure command line to create a cluster, and we have connected to the cluster using kubectl. And we have also learned to monitor the jobs using the Kubernetes dashboard and also the Selenium Grid console. So that's all from my side. If you have any questions, please write to my email address below. Thanks for listening. Goodbye.